Dimensional analysis. The first thing we learn, what is dimension? Basically, the dimension of a physical quantity are the power to which fundamental units are raised in order to obtain unit of that quantity. Hence here we are raising the powers of fundamental unit. Why we are raising? To obtain unit of that quantity. Now let's see one example. Basically here, symbol for dimension of fundamental quantity. Generally, when we are writing dimension, length we are writing by L, mass we are writing by M, time we are writing by T, temperature we are writing by K or theta. We can use K as well as we can use theta for temperature. You know that K is the Kelvin, or theta we can use. Current we can use I or A. Luminous intensity we are using CD, and amount of substance by mole. Generally, it means that we can write dimension like this: L raised to something, M raised to something, T raised to something, K or theta we can use K raised to something, then I or A, I raised to something, then CD raised to something, then mole raised to something in a closed bracket. In this way, we are writing a dimension of any quantity. So dimension formula, basically you can see a dimension of a physical quantity P. So that we can write like this: M raised to X, L raised to Y, T raised to Z. If this term is related to temperature, then K raised to something also we can write. Then if it is related to current, then I or A raised to something we write. So basically X, Y, Z are dimensions of fundamental quantities M, L and T respectively here in this case. Now after that, let's see some examples, dimension of some physical quantities. So dimension of length, it's a fundamental quantity, length. So dimension is L raised to 1. So M0 T0 because length is a fundamental quantity. So we are written. Mass is also fundamental, so M raised to 1. Time is also fundamental, so T raised to 1 is the dimension of time. Now area. Now area is a derived quantity. So for derived quantity, we require a formula. So formula of area, you can use area of rectangle length multiplied by breadth. So we have to substitute dimension of length, so which is this, and dimension of breadth. So breadth is also one kind of length, so both the dimensions are the same. After doing multiplication, and here we can use a law of indices. So L raised to 1, L raised to 1. So L raised to 1 multiplied by L raised to 1. So it is L raised to 1 plus 1. So it's a multiplication, so addition of the power because base is same. So law of indices we have to use. You know the law of indices, A raised to M into A raised to N. So A raised to M plus N. So A raised to M divided by A raised to N. So A raised to M minus N. So A raised to M raised to N. So A raised to M into N. These three are the law of indices which we have to use here. So here we get L raised to 2, L raised to 1, L raised to 1, L raised to 2, M0, 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 T0 or T0, then we get T0 here. So after that, area. So here we use area of rectangle, but you can use any formula which are related to the area. So you can use area of square, length square. So dimension of length you can write and you can square it. You will get the same dimension. So listen. So by using this dimension, you can write the unit of the area. So L raised to 2. Unit of L means length is meter. SI unit I am writing. So meter square. Mass M raised to 0, T raised to 0 means no need to write anything. So meter square is the unit of area. Similar manner, now next one is the unit for volume. So any formula of the volume which is known to you, you can use to find out dimension. So here I use length multiplied by breadth multiplied by height. So it's a volume of any glass slab which having length, breadth and height. So length, breadth and height dimension we have to substitute which are similar to the dimension of length. Then after finding this final dimension we get L raised to 3. L raised to 3 means meter cube. So M0, T0, so forget it. So or you can write the same dimension like this way also. So in a closed bracket L raised to 3. So M0, T0 no need to write. So this is dimension. So by dimension we can write unit. Now next one is dimension of density. Now you know that formula of density, mass upon volume. So dimension of mass, dimension of volume. So I substitute both the dimensions and then we have to solve the division by doing by using a law of indices. So L raised to 0, L raised to 3. So 0 minus 3 minus 3. So L raised to minus 3. 1 minus 0, 1. 0 minus 0, 0. So L minus 3, M1, T0. This is dimension of density. By this dimension, you can write unit of the density also. So length raised to minus 3. So meter raised to minus M raised to 1. So kg raised to 1. Or we can write kg per meter cube. So this is dimension of density. Then after the density, velocity. Velocity is the displacement by time. So displacement means shorter length between initial and final position. So displacement having a dimension of length, time dimension we know. So after substitution of these two, we get, and solving this, we get dimension of speed, and it is L1 M0 T raised to minus 1. I hope everyone understood how we are solving this one division. So by using law of indices, so 1 minus 0, 1, 0 minus 0, 0, 0 minus 1, so minus 1. So T raised to minus 1 is coming here. So again, you can write a velocity unit also. Length raised to 1 means meter raised to 1 divided by or time raised to minus 1. So second raised to minus 1. So meter per second. This is the unit for velocity. Now next one is momentum. So formula of the momentum is mass into the velocity. The mass dimension is L0 M1 T0. Velocity dimension just we already obtained velocity speed having a same dimension L1 T minus 1. So after doing multiplication, L0, so here L0, L1, 0 plus 1, 1. So M1, M0. So 1 plus 0, 1. Here T0, T minus 1. So addition of these two is coming minus 1. So we get dimension L1, M1, T raised to minus 1. It is a dimension of momentum. Now next one is acceleration. Acceleration is change in velocity by time. So dimension of velocity divided by dimension of time. So this is the dimension of velocity L1 T minus 1. Dimension of time is T raised to 1. After solving this, we get L1. So 1 minus 0, 1. 0 minus 0, 0. Minus 1, minus 1, minus 2. So this is dimension of acceleration. By using that, we get unit is meter per second square. So length raised to 1, so meter raised to 1, and time raised to minus 2, so second raised to minus 2. So this is the dimension of acceleration. Now after that, the next one is force. And force is a mass into acceleration. So dimension of mass multiplied by dimension of acceleration. This is dimension of mass and this is dimension of acceleration. After finding the multiplication of these two, we get L1 M1 T raised to minus 2. And this is dimension of force. So you can write a unit of force meter kg raised to 1 and second raised to minus 2. So this is the unit of force. Or you know that unit of force is Newton. This is equivalent to the Newton. So this Newton and this both are equivalent. Then after that, impulse. Impulse is force into time. So unit of force is L1 M1 T minus 2 and time is this. After doing the multiplication of these two, we get L1 M1 T minus 1 and this is the dimension of impulse. So you can see a dimension of impulse and dimension of momentum both are same. Work. Formula of the work is force into displacement. So force is L1 M1 T minus 2. Displacement is L1 M0 T0. After doing the multiplication of these two, L1 and L1 here, L1 plus 1, L raised to 2 and M1 T minus 2 is the dimension of work. Unit you can write meter square, kg raised to 1, second raised to minus 2 and this is equivalent to joule. Now after that, pressure, force by area. Unit of the dimension of the force divided by dimension of area that we substitute here. After solving this, we get L raised to minus 1 m1 t minus 2. This is dimension of the pressure. You can write unit by using that. And unit of the pressure, you know that Newton per meter square or Pascal. And it is equivalent to how much? It is equivalent to kg, means mass raised to 1, so kg raised to 1, meter raised to minus 1, and second raised to minus 2. So this and this both are equivalent. Then after that, power is work by time. So work is L2 m1 p minus 2 and time is t raised to 1. After substitution of dimension of work and time and solving it, we get a dimension of power, and it is L2 m1 t minus 3. So this is the dimension of power. Then after that, dimension of potential energy. You know that potential energy formula is mgh, mass acceleration multiplied by acceleration due to gravity multiplied by height. So dimension of mass, we substitute, dimension of acceleration we substitute, and dimension of height means dimension of length we substitute. And after doing a multiplication, means here L raised to 0 plus 1 plus 1, so L raised to 2, m raised to 1 0 0, so m raised to 1 and t raised to minus 2. This is dimension of potential. Now you can see this dimension and dimension of work both are same, so that you remember. Any energy dimension, any energy means you can see a kinetic energy also, formula half mv square. It is 1 by 2. M means the mass dimension, v square, this is velocity, and it's square. So after solving this, we get a dimension of kinetic energy, and which is similar to the dimension of potential energy. So dimension of kinetic energy, potential energy, and work done, both means all the dimensions are same. Charge. Now, a very important dimension which are useful in the electricity dimensions. So charge is current into time. Current is a fundamental quantity. So I can use a dimension L0, M0, T0, and I raised to 1. It's a fundamental. So if you are not writing this LMT, then also okay, I raised to 1 you can write. So time is L0, M0, T raised to 1. So we get a dimension L0, M0, T raised to 1, I raised to 1. Or you can write like this well. Dimension of current is ampere raised to 1 multiplied by dimension of time t raised to 1. So we get a dimension a raised to 1, t raised to 1, like this way also. Or you can write instead of ampere, I raised to 1, t raised to 1. So this is dimension. In that way also you can write a dimension of charge. Now next one is velocity gradient. Change in velocity divided by distance is the velocity gradient. Velocity dimension divided by distance. After solving this, we get L0 M0 T raised to minus 1 is the dimension of velocity gradient. I think you know how to solve this. So I'm directly uh, telling you how much is the dimension. So electric potential, work by charge. So dimension of work L2 M1 T minus 2, and dimension of charges we obtain I1 T1. After solving this, we get a dimension of electric potential, and it is L2 M1 I raised to minus 1 T raised to minus 2. So this is the dimension of potential, electric potential. After that, it is very important. Physical quantities having a same dimensional form. Many physical quantities you have to learn in the next chapters also. Means here we are not able to. Here it is very difficult to cover all the physical quantity dimensions. But here you remember some physical quantities having a same dimensions. So distance, displacement, radius, light year is the unit of distance, wavelength, radius of gyration. These having a dimension L. L raised to 1. Velocity, speed, velocity of light having a dimension L t raised to minus 1. Acceleration, acceleration due to gravity, intensity of gravitational field, centripetal acceleration, they having a dimension of acceleration means L raised to 1, t raised to minus 2. Nothing is written means it is L raised to 1, that you remember. So, or you can write M0, L1, T0. Nothing is written means it is power is 1. Then after that, impulse and change in momentum that we already obtained here. they're having a dimension, similar dimension. M1, L1, P minus 1. So this is dimension. Then after that, force, weight, tension, thrust, all are having the same dimensions, and which is equal to the dimension of force M1, L1, T minus 2. You remember the dimension of force, which is useful in the many dimensions. So dimension of force you have to remember. The next one is work, energy, moment of force, torque, moment of couple, they having the same dimension. Now, what is torque? What is moment of couple that we learn in the other chapters? Now, next one is force constant, surface tension, spring constant, energy per unit area. They having the same dimension. Angular momentum, angular impulse, Planck's constant having the same dimension. Then angular velocity, frequency, velocity gradient, decay constant, rate of disintegration. They also having the same dimension, it is t raised to minus 1. These quantities you have to learn in the other chapters. Stress, pressure, modulus of elasticity, they are having same dimension. Work, energy, momentum, moment of force, torque, they are having the same dimension.